Well, after defining the truncated budget constraint, we can define also the modified demand correspondence. Here there is omega, here there is omega plus E. As before. In reality, the optimal point would be this point. This is dH of P. But when you consider the truncated budget constraint, for example, the optimal point is this. So you have a modified demand correspondence, which associated with every price system a set of points which maximize preferences or utility in the truncated budget constraint. And generally speaking, this set is different from this set. Now consider equilibrium for the truncated economy. You have a price system P star and a set of consumption vectors H star 1, H star H for every household, such that the sum of these X star H must be equal to the sum of omega H. Here, since we have a pure exchange economy without free disposal, you obtain this result in equilibrium. And for every H, X star H must belong to the cap H of P star. Each of these consumption bundles must be optimal for the corresponding subject. This is equilibrium for the truncated economy. I shall prove now that this equilibrium is in reality an equilibrium also for the original economy, without truncation, so to speak. By started preferences. Let us draw the same graphic with some adjective elements. This is as before. Produce budget constraint. This is omega H. Consider the optimal solution for our consumer. X star H. Note that X star H has all the components lesser or equal than the total initial endowment. In equilibrium, this is obvious because the sum of these vectors must be equal to omega, the total initial endowment. So the singular, the individual optimal bundle must have all the components lesser or equal than omega. So say this is the point, X times H, which is optimal in the truncated economy, in the modified economy. Now, let us return to the original budget constraint, BH of Q. Start. It is possible that in the original budget constraint there is a vector which is preferred to this vector, and therefore when you pass from the truncated economy to the real one, x star h is not the optimal point. So you must have something like this. There is a bundle xh in the real budget constraint, which is preferred, which is lies of Heidegger in different schools with respect to x star h. Is it clear? But this is impossible by starredness of preferences. When you unite x star h with xh, all the points along this segment must be preferred to x star h by this property. In particular, a point like this, say yh, which has all the components less or equal than omega plus e, but some component greater than the corresponding component of omega. So this yh belongs to the modified, to the truncated budget constraint, and it is preferred to the optimal point. Impossible. This different school is not compatible with starredness of preferences. Therefore, it is impossible that in the real budget constraint there is a point which is preferred to x star h. And this means that x star h is the optimal point also in the real budget constraint. This is the result. Since this holds for every consumer, the equilibrium of a modified economy is also an equilibrium for the original one. I repeat the illustration, so to speak, of a proof. Consider our modified economy. An equilibrium for that economy is defined in the same way as the traditional one. Vector P star, H star y, etc., H star H, such that the total consumption is equal to the total endowment, pure exchange economy, and for every subject, x star h is optimal in the modified, with respect to the modified demand correspondence. So, for example, look at this graphic. The optimal point is x star h. Note that x star h must have all the components less or equal than omega, not only of omega plus e, but also of omega, because of this equality. So, the problem is that x star h cannot be in this point. It must be an interior point of this large set. Question: is it possible that in the real budget constraint there is a vector xh which is preferred to x star h? If it were the case, when you pass from the truncated budget constraint to the real one, the optimal point ceases of being such. Is not the optimal point in the real budget constraint. This is not possible by starredness of preferences, because if xh is preferred to x star h, all the points on the segment which unites x star h and xh must be preferred to x star h itself. For example, this yh, which is, however, in the truncated budget constraint. Conclusion: this point would not be optimal. If x star h were at this point, the argument does not run, but this is possible that the equilibrium x star h is here. It must be in this smaller rectangle. And so there is a way to find a point in the truncated budget constraint which is preferred to x star h. In this way, Debré succeeded in avoiding the problems connected to the fact that for some price system with some null component, consumers' choices are not always defined, by simply introducing this particular property of preferences, by modifying the economy and by proving that all the equilibria for the modified economy are also equilibria for the real economy. Let us have another short break.